Aleš specializes, as we know, in Nietzsche's philosophy, the relation of Nietzsche's philosophy to German idealism and its echoes in contemporary philosophy. His research is also characterized by his involvement in various interdisciplinary projects. For instance, Aleš has worked with physicists on the philosophical issue of the existence or non-existence of the void, and you've also been involved in a project to assess the impact of neuroscientific discoveries in the field of law. Aleš has published widely, including monographs on, of course, Nietzsche, but also on, correct me if I'm wrong, Plato and Erasmus.
It was a magnetism of stupidity. The emphasis was on stupidity.
The stupidity was
the other ones who were mentioned were clever men.
So he has published widely, but more recently, he's also published articles dealing with the question of AI, artificial intelligence, but also, I noticed also closer to psychoanalysis, so a different topic on cruelty and perversion. So AI and the more psychoanalytical topics seems to be like new additions, right?
Yeah, I guess so, even though it's not so psychoanalytical, my interventions on cruelty, but mostly still Nietzsche and some other perverse stuff. So,
yeah. Without further ado, the title of Aleš's paper today is Nietzsche, Embodied Errors and the Backpropagation Algorithm. Thank you.
Thank you for this kind introduction. And thank you for enduring me on this session of this sequence of conferences, even though I'm not a psychoanalytical scholar. And I was, as Lorenzo said, I was first invited as an expert for Nietzsche's philosophy, for an author who is kind of relevant for also for the field of psychoanalysis, or at least comparable and so on. But I think I'm starting to find some sort of new identity in this circle, which is more or less connected to the concept of the conference to be continued, because even though in my case I could say that this is the guy who speaks about the same thing each time he appears, and I always speak about Nietzsche's concept of embodied errors, and also this time I will speak mostly about the Nietzsche's concept of embodied errors. So I'll begin with a rather dense passage from Nietzsche's unpublished fragments from the period of the joyful science, which I find relevant for two reasons. On the one hand, it encapsulates well what psychoanalysis has identified as one of the main problems of Nietzsche's psychology, namely its overabundance of drives. While psychoanalysis maintains that there is in fact only one type of drive, the sexual drive, Nietzsche seems to discover discrete drives behind virtually every human condition or activity. And the passage I'm about to quote illustrates this quite clearly. But the passage also reveals something else, and this will form the main line of my lecture, namely a rather astonishing similarity to the basic idea behind the training of digital neural networks. In fact, I see this passage as a kind of final missing piece in a puzzle that discloses a multi-layered resemblance between Nietzsche's epistemology and the actual functioning of AI. Nietzsche's passage runs like this. Science, allegedly on the basis of the love for truth for its own sake, allegedly on the basis of the pure silence of the will. In truth, all our drives are active, but in a special, so to speak, political order and adaptation to one another, so that their result is no phantasm. One drive stimulates another. Each one fantasizes and wants to assert its kind of error. But each kind of error immediately becomes a handle for another drive, e.g. contradiction, analysis, etc. With all these many phantasms, one finally almost necessarily guesses the reality and the truth. One posites so many images that finally one of them hits, like shooting from many rifles at a single deer, a great game of dice, often not playing out in a single person but in several, in generations. Then, where a single scholar asserts even only a single phantasm, and when it in turn is dispelled by another, the number of possibilities in which the truth must be contained has diminished. A success, It is a hunt, end of quote. The basis of the similarity I'll be trying to outline can be summarized in 2 points. First, in the passage we just read, Nietzsche proposes a rather wild idea that truth and reality are ultimately attained through an almost infinite negative selection among erroneous guesses, or as he puts it, various drives' very own fantasies. And this is, I believe, as simplified as it may sound, also the basic idea behind the so-called backpropagation algorithm, which forms the core principle of training digital neural networks. Secondly, it is not difficult to observe that within the logic of Nietzsche's idea, the correct recognition of truth or reality, though it does take place, does not occur in any substantive sense, nor does it manifest as a discrete epistemic event. Since it results from a combination of a gradual negative selection among phantasms and a fortunate guess, it must be grasped as occurring within the gravitational field of the erroneous. Or to put it differently, ontologically speaking, correct recognition, though it occurs, remains an error. It belongs to the same order as any other phantasm. There is nothing that qualitatively distinguishes it from them. And I will try to show that a reflective examination of how digital neural networks are made to function may lead us to the same conclusion. But let's be honest, there's something suspicious about trying to throw into the same pot a 19th century existentialist who despised mathematics and a cutting-edge contemporary scientific invention like AI, which above all else depends on mathematical solutions. To at least partially dispel this well-founded mistrust, I'd like to begin by pointing out a couple of relevant facts. First of all, Nietzsche developed a rather unique epistemology, one that was in itself highly critical of traditional epistemological approaches for failing to consider the biological and evolutionary conditions of human emergence, as well as the ways in which these biological preconditions have shaped and continue to underpin how we think, sense, and experience. To express this view, Nietzsche coined a short but powerful formula. Our apparatus for acquiring knowledge was not designed for knowledge. And let me immediately point out that an equivalent of this idea also appears in neural network theory. According to Nietzsche, as long as epistemology treats the human cognitive and sensory apparatuses as having been designed from the outset and finely tuned for the acquisition and generation of knowledge, it fundamentally misinterprets their true origin. For Nietzsche, these apparatuses were in fact developed for something quite the opposite. They initially evolved as mechanisms for sustaining those vital errors which over the course of the primary formation of the human being proved necessary either for the preservation of the species or for the enhancement of its power. Among these necessary, vital, and determining errors, Nietzsche referred to them as embodied errors, einverleibte Irrtümer, are such fundamental aspects of our experience as experiencing oneself as an ego, the perception of the world as divided into existing entities, the very notion of the existence of entities, our internal experience of consciousness as structured by the subject-object relationship, and even the concept of being itself. All these apparent facts of consciousness, all these apparent certainties, belong, according to Nietzsche, to the category of embodied errors. And the reason these representations and inner experiences appear all but undeniable lies in the fact that our sensory and cognitive apparatuses evolved predominantly as tools for their maintenance or as levers designed to keep these vital errors in place. Only much later, they got relatively emancipated from this function. On the other hand, however, this does not mean that embodied errors are purely fictional or devoid of reality. On the contrary, as specific key adaptations to the demands of survival or power, capable, in Nietzsche's words, of organic manifestation and organization, they embody not only errors, but also instincts or drives. In fact, during the same period in which he wrote the passage quoted above, Nietzsche made this connection explicit by implying that embodied errors are, in fact, the same thing as drives. Now, surely such a direct translation of biological determinants into the very structure of subconscious drives raises questions from a psychoanalytical standpoint. However, given the task at hand, I must focus primarily on the epistemological dimension. In fact, we have already encountered two relevant points of focus. The first is the emphasis on the biological, and the second, which I shall refer to here as epistemological primacy of error, refers to the previously illustrated Nietzschean belief that the primary formation of the human condition was not shaped or manifested by any form of common human knowledge, but rather by a coordination among various types of vital errors commencing to run smoothly and with some regularity. And we shall see that both of these topics also form significant focuses in neural network theory. There is, however, I believe, also a third point of convergence, one that is more generally epistemological in nature. Given Nietzsche's conviction that our apparatus for acquiring knowledge has not yet even fully emerged from its opposite, from the very form in which it was hatched, it is perhaps not surprising that the key epistemological question for him was not how is knowledge possible? Or at least we should say that while this question remains present in his thought, it loses some of its centrality. In its place, Nietzsche introduces seemingly simpler, yet in fact, perhaps more fundamental questions, such as what even is knowledge to begin with? Or what does it even mean to understand? Or to put this still differently, since all our knowledge is conditioned by vital mistakes, which implies that all our knowledge is in this respect relative to error, epistemology can no longer revolve around the category of true knowledge and its conditions. Instead, it must focus on the underlying structures of knowledge and understanding in which their relation to original and conditioning errors remains palpable. But let us now turn our attention to digital neural networks. As some of the key figures in the so-called artificial intelligence revolution have themselves pointed out, the astonishing development of AI should not be viewed solely as universal progress within computer science, as the straightforward outcome of mathematical and technological breakthroughs, the ever-increasing computational power of computers, and the very existence of immense storages of digital data. Of course, all of these elements are fundamental. However, the current development must also be understood from another angle, as the result of a prolonged and often bitter struggle between two fundamentally different approaches to achieving artificial intelligence, each grounded in a significantly different scientific paradigm. What is quite significant here is that the side which eventually emerged victorious, the so-called biological or connectivist paradigm, had for a long time been considered the underdog in this competition. This immediately brings us to the following, I believe, central question. What does biological mean in the context of digital neural networks, which are, after all, mathematical models composed of numbers? On the surface, the term biological clearly refers to the fact that digital neural nets were initially inspired by the structure of the biological brain, particularly its networks of neurons. However, as I will try to show, this reference to the biological original does not fully exhaust the meaning of the term biological in this context. Now, probably you've all heard of Geoffrey Hinton, one of the greatest minds of our era, who together with John Hopfield was awarded the Nobel Prize in Physics for their foundational work on artificial neural networks in 2024. Hinton was, alongside David Rumelhart and Ronald Williams, one of the scientists who, as early as the mid-1980s, discovered that an algorithm called backpropagation could be efficiently applied to digital neural networks as a fundamental principle for their training. And this breakthrough is now regarded as one of the most pivotal steps in spectacular development of AI that we are witnessing today. And basically all now these large language model systems are based on backpropagation. What some of you may not know about Hinton is that for a shorter period, the man also studied philosophy. And even though he soon discovered that philosophy didn't meet his expectations in trying to understand the human mind, the propensity toward expressing himself somewhat philosophically never left him. In fact, it was a phrase often repeated by Hinton that initially caught my attention and led me to consider the similarity with Nietzsche. Although quite simple, this phrase not only encapsulates the difference between the two competing models of intelligence, but also seems to offer a further explanation of what biological means in the context of AI. I quote, "Reasoning came much, much later. You don't learn it until you are very old. Reasoning is a very bad model for biological intelligence. Biological intelligence is about controlling your body and seeing things." End of quote. So what Hinton is basically trying to express, I believe, is that it is impossible to correctly pinpoint the edifice of the biological brain as long as we conceive of it as primarily adapted to processes such as reasoning, by which he predominantly means logical thinking, or things like understanding, thinking in general. And the reason for this is that such processes emerged too late within the evolutionary development of biological intelligence to have played a role in its primary formation. A formation that had been unfolding for millions of years in tandem with the development of functions like body control and sensory apparatuses. Or Nietzsche would add here, most certainly, digestion. Digestion is Nietzsche's own example of biological intelligence. He thought that digestion is, in fact, more intelligent than the brain. Of course, the brain later had to adapt specifically to tasks such as reasoning, which undoubtedly rely on neural activity patterns distinct from, say, those involved in motor control or digestion. But this adaptation still had to occur on a pre-existing foundation, one originally developed for entirely different purposes. I believe Hinton's phrase, "reasoning is a bad model for biological intelligence," bears more than a passing resemblance to Nietzsche's central thesis, "Our apparatus for acquiring knowledge was not designed for knowledge." After all, it was Nietzsche who introduced the concept of the too lateness of phenomena such as consciousness and truth. For example, I quote, for both examples are from the Joyful Science. "Consciousness is the final and latest development of the organic, and consequently also what is most unfinished and impotent in it." Or again, only very late did the truth appear as the least strong form of knowledge. But let us dig a little deeper into Hinton's account of the rivalry between the two models of intelligence that shaped and ultimately determined the course of AI development. I quote again, "There are two models of what intelligence is all about. The first model is all about reasoning, and the way we reason is by using logic. That's special about people, and what we should be doing is understanding what kind of logic we actually use. That also went with the idea that the knowledge we store is symbolic expressions. So that I can say a sentence to you and you will somehow store that, and later you'll be able to use it for inferring other sentences. What is inside your head is a bit like sentences but cleaned up. And then there is a completely different model of intelligence, which is all about learning the connection strengths in a network of brain cells. And what it is good for is things like perception, motor control. That was an entirely different paradigm, and it had a different idea of what's inside your head. It's not stored strings of symbols, just the connection strengths. For the symbolic AI, the crucial question was, what is the form of these symbolic expressions and how we do reasoning with them? For neural net view, the question was quite different. How do we learn the connection strengths so you can do all these wonderful things? For neural net view, learning was always central. For the symbolic AI view, not so. They said, we'll worry about learning later. We must first know how knowledge is represented and how we reason with it. So these are two totally different views. One took inspiration in logic, one from biology. And for a long time, people from the logic camp thought taking inspiration from biology was quite silly. End of quote. I find Hinton's explanation very clear. From a philosophical standpoint, what matters most is that the symbolic AI model aligns with the traditional epistemological quest for the conditions of true knowledge characterized by Nietzsche. Its central premise is that there must be some sort of similarity between the structure of language and the corresponding processes in the brain. What it seeks to uncover is how human knowledge and logic are represented in the brain and to devise machines capable of supporting their functioning, almost some sort of transcendental machinery. The biological model, on the other hand, revolves in every possible way around the key concept of learning, a concept traditionally associated with experience and therefore with empiricism. However, in the context of neural networks, it is, I believe, better understood as a form of accelerated microevolution. So ultimately, it all comes down to a central question. How does the learning process of digital networks actually work? Which brings us back to backpropagation. Obviously, a very simplified definition might be: backpropagation is an algorithm that retroactively calculates the error deviations in the system's operation, thus allowing for the elimination of those connections in digital networks functioning that rank highest in this error coefficient. In short, it allows gradual elimination of all those connections that most strongly steer the system's functioning towards error. In this way, the algorithm, through an almost innumerable number of iterations of the described procedure, gradually leads the system to optimize its performance according to externally defined criteria of correct behavior. Whereas Hinton himself describes this operation, so the magic is that there is this relatively simple algorithm called backpropagation that takes the error in the output and sends the error backwards through the network and computes through all the connections how you should change them to improve the behavior. And surprisingly, that actually works. But let us try to describe the process in our own extremely naive, I emphasize, simplified, I would say, intuitive way, still in a little more detail. The first step in training a digital network goes something like this. The system is asked a question and responds with an answer. I put the word answer in quotation marks because in reality the system's response has nothing to do with the question, but consists of a purely arbitrary reaction that is registered in the system's numerical parameters which allow its modification. This response therefore contains no knowledge of the question, not even the slightest hint of a correct answer, nothing on which a process of cognition could rely. And the irony is that this does not change at all, even up to the end of the process. The important point is that the system provides several of these absolutely contingent answers. They all enter into numerical parameters of the system, and of course, none of them contains even a glimmer of correct knowledge. But even if none of these answers contains anything that points to the correct answer to the question, it nevertheless, through its relation to other answers, does contain something, namely a comparatively measurable degree of its falsity in relation to what we assume constitutes the correct answer to the question. Or to put this even more simply, some answers are, purely by chance of course, nevertheless less wrong than others, closer to our external estimate of the correct answer. And in this triangle, between the individual answers and what we have determined to be the correct answer, it is actually possible to calculate something, namely a kind of coefficient of error which allows us to adapt the parameters of the system to those answers which happen to be least wrong. In this way, gradually, through almost infinite series of iterations, we adjust the system, optimize it until the optimized system, from which we systematically extract the maximum deviations in the direction of error, at some point, again purely by chance, except that this chance now has narrowed coordinates, does not give a response that overlaps with what we see as the correct answer to the question. And then we adjust all the parameters in the system in such a way that this phenomenon of correspondence is repeated as many times as possible. Obviously, this last answer, despite its overlap with our assessment of correctness, is no closer to the characteristic of correct recognition than the original, purely arbitrary response. Nevertheless, the system taken as a whole, from which we have excluded all the connections that led it to error, begins to behave or to recognize correctly. Eventually, once the procedure has been repeated millions of times on various examples, it begins to give correct answers of its own accord to many other questions which are not even related to the original ones. In short, to produce the effects of intelligence. Now, obviously, this was extremely simplified explanation, which does not involve any mathematics. But nonetheless, this is not so much important for the point I'm trying to make, because I think that all of this leads to a single conclusion from a philosophical standpoint. Correct recognition occurs as an effect without ever having taken place. The fundamental building blocks of digital network training are errors, the calculable relations among them, and a purely arbitrary external estimation of veracity. Correct recognition is merely a surface effect without any foundation of its own. It is an error reduced to almost nothing. But let us turn this around in another way, and I'm going to finish with this. We can observe that despite the fact that digital networks are entirely constructed as mathematical models, there persists in them something born and emerging out of chance non-mathematical. An error is not, after all, a mathematical operation. Of course, mathematics can define it, measure it, calculate it, but the initial response of the system, which, so to speak, bestows on us the first error upon which mathematics can then operate, is contingent. And this contingency behind it persists in the process all the time as its central factor, which the mathematical calculation of the error merely selectively steers in the direction of its minimization. This is, in fact, I believe, one of the potential meanings of the word learning. In a sense, it denotes the non-mathematical in the midst of the mathematical, the trace of the biological that nonetheless doesn't necessarily relate to the actual working of the biological brain, because as we know it, the backpropagation algorithm works according to principles which are very different from the ones of the biological brain. And in fact, taking all this into consideration, shouldn't we say that this process called training or learning, which drives the development of intelligence from the 0 point of absolute contingency in the first answer, through the experience of extreme inclinations towards error that determines selection, to the eventual effect of correct cognition or of intelligence, is a kind of microevolution accelerated and condensed to the extreme. One that Nietzsche described quite correctly in 1881. Thank you.
Thank you, Alex. Yes, let's open the floor to questions. Yeah.
Hello. Thank you for an excellent talk. My question concerns an issue of intentionality within AI. So you explained that the sort of corresponding passage from Nietzsche identifies the ego and the subject-object relation as all these as embodied errors, right? Does it not strike you that, so would you say, how would it then, if we sort of extrapolated the analogy, would it be possible to induce a sort of more complex behavior within a system through backpropagation that enables the system to set its own weights, if that makes sense?
You want to say basically if I understand correctly, if you could induce the artificial network through backpropagation, basically to incorporate also the intentional structure of the consciousness.
Sorry, I don't want to sort of go so far as to consciousness. I guess in sort of terms of the network structure, I guess my question is that for the backpropagation algorithm to operate, there necessarily has to exist a sort of external reference, right, which we compare against.
Yeah.
Do you see it as a sort of second order operation that is sort of beyond the capacity of the algorithm, I guess, metaphysically, right, to incorporate that externality within the process itself?
Okay, I understand, because this is also, I was thinking about this, because this is also when you compare, for instance, Nietzsche's example and the backpropagation. In Nietzsche, you don't have that criteria. Now we know that the correct answer has been reached. And it's obviously, this is one of the central problems of the entire period of Nietzsche, was precisely this kind of it's rather surprising. This is the middle period of Nietzsche's work. And his central problem was basically, I think I was talking about this already on these conferences, his central problem, Nietzsche is usually associated as a relativist of thought, a relativist story of truth, and so on. But during this period, this is also the period when the eternal recurrence appears in 1881, 1882, his central problem was basically how to smuggle truth into life. And so we have some sort of truth which suddenly appears, and we have to kind of make conditions for its survival within the world which is dominated within our psyche, dominated by embodied errors, which structure us, which dominate in a way our brain, and so on. And on the other hand, there was this kind of worry that the emergence of truth may cause a collapse of our psychic apparatus. And so in his case, it was like some sort of truth has started to emerge, and he does not even. I usually refer to that truth, which is here very much related to the topic, which is the truth of the non-existence of substances, because it is very much connected. Because in fact, the main effect of embodied errors is substantialism, but not substantialism as a philosophical doctrine, but substantialism as an effect of language from which we cannot escape. So we are in a way caught here. But nonetheless, we know that substances no longer exist. So there is some sort of this kind of the truth has somehow emerged. We don't know exactly how, here is this significant difference. But your question, I guess, that Nietzsche's example says that in some way, yes, the answer is yes, but it is not so important if it is kind of an ultimate check of veracity, or is it another embodied error?
Mm-hmm. Yeah, thank you.
Thank you. I have a related question, which is to do with this idea that you propose that the embodied error has to do with an infinite kind of retraining. And it strikes me that this is not the case in a lot of AI, where there is a problem in a lot of AI of overfitting, right, which is training too much to the data. And so the issue of training a neural net with backpropagation is solved not through an infinite not through infinite steps of learning, but through a certain curated number of steps of learning such that it will be able to perform the function that the trainers think will be appropriate to what they are training this thing to do. And this is a kind of collapse in the distinction between the symbolic and the connectionist sides of the history, where the connectionist approach is to approach a sort of symbolic logic that is the same as the symbolic side. It is just to do it through a different means. They have this idea of the universal approximation theory, which is that any function can be approximated through an appropriate number of steps in the learning process. So I wonder if this, how much your account of the relationship between backpropagation and Nietzsche's idea of embodied error relies on this idea of an infinite and continual kind of steps in learning, or whether there is, can your approach account for overfitting?
First of all, thank you for the comment itself. It's very elucidating. I'm also still learning. It's a new topic also for me. This artificial intelligence, and I have to state here that I'm extremely surprised that I understand anything at all, because I'm genuinely stupid for mathematics. I mean, I don't understand anything about mathematics, so it was just kind of getting some sort of fragment which kind of made sense, I thought, and I still believe to some degree. But no, also your question is great. I think that I think it touches upon one very significant topic of also of this period of Nietzsche, and also of I think of his entire way of thinking during this period. I think very important for him is some sort of speculation on the basis of very big numbers. Of immense amounts of time, for instance, or not necessarily immense, but I said before that this is the same period when also the thought of eternal recurrence appeared, which is basically based on a difference between enormous quantity and infinite quantity, which is if time is infinite and if what exists in time consists of almost an infinite but still not a quantity of forces which enter into dynamic relationship, then at a certain point a certain constellation of forces which already existed has to reappear. And I think that here he's doing basically something the same, but it is very astonishing that he is not only, it's not just kind of this sublime impression of the infinite, but he's putting something, it certainly doesn't work, this passage, if you don't put in some sort of enormous quantity of repetitions. Now, obviously, is it infinite? No, here it couldn't be infinite. It is in a certain way finite, because at a certain point, it must be, the number of possibilities must be exhausted. This is basically, I think.
We have time for a couple of more questions. I'll ask you a question. Well, thank you. It was like wonderful, and also like a wonderful continuation on the Nietzsche you have been presenting to us in this context for a couple of years. I wanted to go back to one of the main ideas where you find, we can call it the analogy between Nietzsche and the backpropagation algorithm. That is to say, the idea that we're dealing with either a machine or a brain, an apparatus, as you said, which acquires knowledge contingently. It was not designed for knowledge. I'm paraphrasing something you said. My question is broad, but I think it forms a kind of like triangulation with things you said, especially when you bring in biology. Once you find these analogies, an analogy in a certain modern philosophy, if not metaphysics, with Nietzsche, and then in something which is really happening now, and we can't really understand it, i.e. AI, is how to triangulate it with mainstream or post-mainstream Darwinian biology, right? Because obviously a kind of like teleological Darwinism is destroyed by this. I mean, not just by Nietzsche, but the very reality of a backpropagation algorithm. So that would be like, I would say, like an instantaneous answer to give, right? I mean, mainstream Darwinism is over. But then, if you think of like more materialistic and more contingency-based forms of Darwinism, such as Stephen Jay Gould, etc., when you start replacing the idea of adaptation with the idea of acceptation, I was thinking that could be another, vertex in the triangle you are delineating. That is to say, it's not the struggle for the best survivor, if you want to put it like that. It's adaptation is acceptation neologism by Stephen Jay Gould. It's a retroactive process. And I was trying to figure out, as you were speaking, whether there is like a partner in dialogue there. So, like the usual example is like, feathers we know biologically were not designed as contributing to flying wings, but they were they had a thermical function, and retrospectively, feathers will have been wings, right? It's something like that. I don't know. Do you see like a connection with this stuff in more recent Darwinism, or is it the end of Darwinism?
No, I think there is certainly potential, and I was to some degree surprised when you said this is the end of Darwinism. Of course, Nietzsche's evolutionary theories differs. He was very critical of Darwin. I don't think in correct sense. I think that the main he was largely indebted to the idea of evolution. Nietzsche is the evolutionary epistemologist. I think this should be stressed. And there are obviously these differences in which are to some extent, I don't know, will to power against survival and so on. But will to power comes later. This is not yet the era of will to power. But I think that also in Darwinism there is this kind of emphasis. I remember Marisa was actually talking about this once, about this kind of a necessary mistake by nature which enables a survival, but she'd had to elaborate on this. I just remember this example, and I'm not sure where from it is, but most certainly there needs to be this elaborated in this direction. Yeah.
Great. We have time for one more question, comment. Okay, well, let's thank Aleš for a great paper. Thank you.